Okay, so we'll start now. So, welcome to the weekly live discussion for week 10 of the course Foundations of R Software. So, I'll start sharing my screen. Please confirm if I'm audible and also if you can see the R Studio window. So, you can see the screen, right? Very well. So, the majority of last week's discussion was based around strings and the operations that we can do in strings. More specifically, we were focused on the inbuilt functions provided by R that allows us to manipulate strings. So we'll wrap up that discussion by summarizing a couple more string methods, and then we'll move on to a discussion on data frames, which is the primary subject of this week's lectures. So okay, let's define some strings. So I can say my 5th birthday is in 5 days. So this defines a new string for me. Now we may be in a situation where we just want to modify a part of this string. So in that case, it's not always advisable to define a new string again and again based on small changes. We can utilize this string and make some changes within this string itself, or we can store those changes as a new string. So a couple of functions that can be helpful in that situation. So first one is called sub, or which is short for substitute, and it basically looks for a pattern. So you have to tell what pattern you want to replace. So since we are working within strings, that pattern also has to go inside double quotes. So I say I want to replace 5 by, let's say, 6. And where do I want to make this replacement? That is the third argument. So that will be the string. So I want to make this replacement inside S1. So notice I am not storing this in any variable. I'm just calling this, and as you can see, what this does is it looks for the first occurrence of this first argument. So you can think of this as substitute, and the 3 arguments are old, new, and the string. So the old substring or the old expression that I want to replace is just the number 5, and I want to replace it by 6, and I want to do this replacement inside the string S1. So as a result of this, what this does is it looks at this string and see where this expression appears for the first time. So this 5 is the first occurrence, so it only replaces that one and gives you the answer. The second 5 is left untouched. So that's where a variation on this method becomes useful, which is called G sub or global sub, which means you replace all occurrences of this expression. So let's say if I do this, so S1 had 2 5s. If I'm doing a global substitution, both the 5s are converted into 6s. Now this does not have to be restricted to, single character expressions. You can do more complicated stuff. So instead of saying my 5th birthday is in 5 days, this is saying my 5th birth year is in 5 years. So it's just a dummy example, so it doesn't really have to make much sense, but you can see the action here. And similarly, if instead of G sub we had used just sub, then only the first occurrence is changed. So this is my original string. It contains this expression day inside it in 2 places. Global substitution, replaces both of them by this new expression. But the single substitution only looks at the first occurrence and changes that. Now, other than replacement, sometimes what you want to do is you want to search. So you have a large amount of text-based data, and from that you want to identify where a certain expression or a certain phrase appears. So let's say the function that we are interested in is called grep, and there is a variation of it called grep-L or grep logical. So let's look at the documentation for this function. So you basically look at a pattern, and that pattern has to be looked at within something, so within some string. You can specify whether you want to match the case or not. So if you say ignore.case equals true, capitalization or capital letters, small letters, or a mixture of that will not make any difference. Now there is also a value provision. So what it returns usually is just so you provide a pattern, or you provide, let's say, a vector of strings, then what grep will return is just a vector of where exactly this pattern exists, or in which of the components or elements this pattern exists. But if you say value equals true, it also prints that value. And there are other arguments as well, and there are other variations of this that one can look at in details depending on the necessity. But let's say we write something. Let's clean this up. We'll write, let's say, str collection. So it's a collection of strings. Okay, so say I like to write code. There's another one we can say coding is my hobby. Can you believe this? Okay, so we have defined a collection of strings, and now we'll feed this to the grep function. So let's say the pattern that we want to match is code, and we want to match this inside str collection. And let's say we are saying ignore case false. What that means is we are going to impose case sensitivity. So code has to exactly look like this. So no capitalizations in between. So if you do that, let's call str collection once. So now you see it's only in the first and fourth elements of str collection that this exact pattern exists. So that's why it's returning the numbers 1 and 4. If you want the strings to be returned, so you also have to give value equals true. So now it's not returning the positions, it's returning the values where this expression appears. And there is a modification of this called grep-L, which is grep logical. Okay, this element. What grep logical does is that for each element of the vector that you have entered, it says whether this expression exists inside that or not. So that is what true, false, false, true is doing. So in the first string, this appears. In the second one, it does not. Also, not in the third one either, but it appears in the fourth one. So that's why it's true, false, false, true. Now, grep is not just limited to R, so this is a very popular command used in Unix based systems to search for files and also for do search across texts. So this has a lot of power, and it's a very commonly used tools amongst those who prefer to work with the command line. But this was just a small sample of how this can be utilized within R. So I think that concludes the discussions on strings. So what we'll move on to next is the topic of data frames, which was, as I mentioned before, the primary topic of this week's lectures. So we have seen several ways of forming collections of data. The simplest was just defining a range based equally separated values of numbers. Another was, let's say we can use this C notation and we define a collection. So I could just say EC AF, something like that. We have also come across lists. We have come across matrices. So these are all collections of data. Now, data frame is a more sophisticated container. So inside data frame, you can think of data frames basically as tables, but now all the entries don't have to be of the same type. So for example, in matrices, so when we were discussing matrices, we discussed an example of matrices storing the marks of several students. But you may store more than just marks in a data frame. So you can store the name, roll number, marks, grades, and a lot more things. So data frame basically allows you to combine numerical values, character strings, even factors, so categorical data, all of them together. So as far as everyday use is concerned, you can think of data frames in terms of spreadsheets. So data frames have that kind of a structure. So individual variables are stored inside columns, and the records, so for a particular key or for a particular person or whatever, that is determined by the row. So one entire row contains all the information corresponding to the different variables for a single entity. One entire column shows information of one kind for all the entities. So to demonstrate the working of data frames, we usually use this package called mass. So mass is basically short for Modern Applied Statistics with S. So that was a book, and S is a programming language very similar to R. The only difference was that S was not open source. It was a proprietary software, so R was developed as an open source alternative. You can see I've loaded mass using the library command. So now I can call things which are stored inside mass. So mass stores a lot of data frames, a lot of functions, a lot of graphical utilities, and so on. So this library was basically defined or created so that when walking through that book, Modern Applied Statistics with S, you always have some toy examples to work with, or you can walk through the code and learn. So we'll use the same example which was used in the lectures. So inside the mass library, there is this data frame called painters, and this contains, so as you can see, this contains 5 columns: so composition, drawing, color. Now of course, because of the limitations of the screen, it is printing the other 2 columns below. So let me call this again and let me expand this. Yeah, so now you can see the columns are basically composition, drawing, color, expression, then this categorical data called school. And these rows correspond to different artists. So row 1 corresponds to the Udine and Da Vinci, Del Piombo, and so on. So as you can see, this is a very similar form like spreadsheets. So now you can do operations on these data frames. So the simplest thing you can ask for is the summary. So sometimes you don't want to look at the entire data frame and then figure out what's stored in there. You just want information. So when you do summary of painters, it's basically giving you a summary of each of the columns. So for example, for the composition, what is the minimum value, what is the maximum value, what is the mean value, what is the median value. Of course, you can also have quartiles, so first quartile, third quartile. Mean is the second quartile, it's in the middle. So similarly for others, so you can see the first 4 columns, composition, drawing, color, and expression, they are numerical. So that's why you get statistical information regarding them. Because with numerical data, you can calculate the min, the max, the mean, and so on. The last column, school, is actually categorical. So it categorizes them into this A, B, C, D, all the way up to H classes. So what is displayed here is the first 6 most frequently occurring classes. So there are 10 entries with school A, 10 entries with school D. So this is in a descending order. Of course, you don't see, so you have A, B, C, D, E, F, and H do not appear here because, of course, their total number or total strength is combined under this other header. So data frames are something that if you are working on statistical projects, working on data science, you will encounter a lot. In some languages, there are specialized libraries. So for example, if you work with Python, you may have heard the name pandas. And for any data frame, you can, basically ask for the description. You can ask for first 5 entries, last 5 entries, and so on. Now, let's say you want information on just one of the columns. Now we have seen that if there is some function which is attached to some object, we use the dot notation. So we say a dot b, and then something will happen. Some action will take place which has consequences on a. But speaking of data frames, when we want to access a certain column, what we do is we use this dollar symbol. Then you can see immediately this is giving me the option of selecting one of the 5 rows. Let's say if I pick colors and then ask for the summary, then this is only printing information relevant to the color variable. So similarly, if I do this for school, so now you can see it's not just giving me the first 6 in descending order, it's giving me everything in the original order and just showing the number of occurrences of each of them. Now just like while defining matrices, we set the number of columns, the number of rows, and we can also name those columns, name those rows. So similarly, you can ask for the column names of, let's say, painters. So these are the column names. And similarly, you have the row names. Now this is one thing is very important that we must remember. What goes in the rows, what goes in the columns, there is a convention to it. So usually, we don't take the transpose of this data frame. So you may think of a situation where composition, drawing, color, expression, and school become 5 rows and everything else becomes columns. But the way things are done is that for a single row corresponds to a single entity. So that entity is this painter, the Udine, and all these variables have certain values corresponding to this row. So in this case, the row basically acts as the key. So the unique thing basically. Because composition, drawing, color, expression, or even school, they can have duplicated values across different entries. But these entries correspond to unique individuals. So that's the convention, that what defines your entity should be a row element, so that all the variable values corresponding to that sit in front of it. So if I have to access Da Vinci, let's say, then I can immediately get the composition, color, and so on. And what defines a particular variable sits in a column. So this entire column can give me all possible composition values corresponding to all possible painters. Now, of course, the regular things that we have learned, so we could ask, is numeric, is boolean, or even convert things. So we can ask similar questions on columns of the data frame. So as you see, school is not numeric. If I ask is not factor, then it says true. Of course, these things were done on an existing data frame. We can also define new data frames. So let's clean this up. So we already have this x, which is a variable from 1 to 10. Y is also there. Now let's define z, which could be a matrix. So let's say the data is just the numbers from, or let's put some subset of the letters. So I put 11 to 20. I put this in, let's say, 5 rows and 2 columns. So let's see. This is what Z looks like. Now I can make a data frame out of these individual data pieces. The command to do that, so let me call that df1, and I'll just say data.frame. And I'll just feed x and z inside this. Or let's put y inside this as well at the end. Let's see what happens if I do that. Differing number of rows, 10, 5, 4. Okay. So now you see, x had 10 elements. So those 10 elements basically become the elements of these columns. I had not provided any specification on these rows, so that's why no names have been assigned here. It's just numerical 1, 2, 3, 4. It's just counting the records. Or you can think of this as serialization. Now as far as the matrix was concerned, this matrix only has 5 rows, but since 5 divides 10 completely, that's why, as you can see, you get the first 5 rows of the matrix and then a repetition takes place, just like we've seen previously. Now calling the data frame with x, z and y did not work because y had 4 elements, and of course 4 does not divide 10 completely. So unlike other containers where we had seen that even if the division was not complete, the repetition would start from the first index. That does not happen in data frames. So just to demonstrate that, let's redefine x and make this 1 to 20. Now if I call the data frame of x, c and y, now this works. So now you can see there's 20 elements in x. x1, x2 correspond to the two columns of your matrices. And then the small y corresponds to this that we have defined earlier. So since this goes all the way up to 20, and this matrix Z had 5 rows, this is getting repeated 4 times. So this is 1 time, and 2, 3, and 4. As far as y is concerned, y has only 4 elements. So 20 divided by 4 is 5. So this pattern will get repeated 5 times. Now if I want to see summary of this df1, now of course x is just a numerical sequence from 1 to 20. So the minimum is 1, maximum is 20. Mean is 20 plus 1, which is 21 divided by 2, which is 10.5. And other quantities are similarly constructed. x1, x2, and y are characters, so that's why it is just mentioning that this belongs to the class of characters, and the storage mode is also characters. So other than the summary, you can also ask for the structure of the data frame, which is by this command known as str. Again, this is one good reason why you should not define your strings with a variable named str, because str is a built-in function. So it's telling you there are 20 observables and there are 4 variables. So observables are basically the number of rows, and variables is the number of columns. And it's giving me the data type of each and what values are stored there. So in x, it goes from 1, 2, 3, 10, and so on. So it goes all the way up to 20. For x1, which is just a dummy name provided by R when I'm constructing this data frame by including this matrix inside it. So that has characters k, l, m, n. x2 has characters p, q, r, s, and y has the characters a, c, a, f capitalized. Just like we had discussed, the dollar-based calling system for the inbuilt data frame, the same thing can be done for this guy. So we can call x and print it, and call y and print it. So now you see, when I'm calling df1 $y, I'm not calling this y, because this y only contains 4 elements. What I'm calling is all the entries of the column named y here. So this contains 20 elements, which are of course repetitions of these entries, but df1 $y and this y, even though this was constructed using this y, these are 2 different things. So should not be confused regarding this. If you want specific entry of df1, so what you can do is you can give the row name and then the column name. So, or a better option is you specify the row name and the column name. So the rows are just numbers here. So let's say I want to look at the 10th row and I want to look at column y. Okay, so in this notation you have to give it like numbers, just like you do for lists. Now another thing to note is there is a command called attach. If I attach df1, that's interesting. Okay, so let's highlight this difference in the action of attach by first attaching it painters and then. Okay, when I attach painters, what that accomplishes is that I don't need to, use the $sign to call specific column elements. So if I just say school, it will return whatever was there. If I just say composition, this will work. Of course, I can always say painters $composition just to be specific what I'm referring to. So return the same thing. but the differences are basically here. So in df1, the names are automatically borrowed. So say x and y borrowed from the way this has been constructed. Now when I'm trying to attach df1, it's saying that the following objects are masked by global environment. So x and y already exist in the global environment. So even if I try to attach df1, there will be an ambiguity what I'm referring to. So you see x is there and y is still the original value, but x1 works, x2 works. So this is where some care has to be taken in defining quantities. So now the reverse of this is just use detach. So we say detach df1. Now if I call x1, it doesn't know what I'm talking about. Similarly, I can detach painters. So now if I ask for the composition column, but painters $composition still works. This attach detach functionality is just for ease of use. So you may not require it, but if you're working in a long program and you're working with a single data frame, then maybe that can be useful. Of course, just like we could do some string operations, we can also search within data frames and try to filter things out. So one such command is the subset command. So let's say as an argument I give painters, or let's say let's go with df1, and I want those x1s which have the value O. Oh, right. There should be double equal sign, that's why nothing happened here. So you see, there are elements where x1 contains O, 4 such elements, and if I want to filter that out, I'll just ask for a subset of the entire data frame. Well, those are basically the 5th, 10th, 15th and 20th elements. And since this matrix was constructed together, so x1 and x2, there is some correspondence. So whenever you have an O at the same, for the same entry, you have a T for the x2. Similarly, you can ask slightly different question. We can ask y equals A. So you see, all the places where A appears, those entries have been highlighted now or printed out now. Now, of course, there is another thing that you can do. You can maybe filter out some columns. So let's do the same thing, but or maybe we ask for everything, but we give a select. So when you do select C minus 1, so this is the same C that we have always seen, the collection function. So but when we address this by numerical values and put a minus sign here, it's basically specifying which rows I want to eliminate. So if I had done -1 and then -3, this is only giving the second column and the fourth column. So these are some things that you can do. Now, of course, there are more ways to filter out data from a data frame. So let's define a variable split df. What we'll do is we'll use a command called split. So first I specify what data frame I want to split, that is df1, and on what basis do I want to split it. let's say I want to split it on the basis of the elements of column Y. So if I call split df, you see categorization has been done. So within split df, there is one data frame corresponding to the Y values being A, the second data frame corresponding to Y values being C, and a third data frame corresponding to Y values being F. And of course you can check, the type of split df. So this is a list, and if I split df $A, that's another list. So you can access individual ones. Now of course, this is only useful if you have repetitions, and categorization based on that column can be done. Because if you do something like, let's say, split df, let's call this split df2, and if you want to split it based on the entries of column X, and this is actually pointless, because anyways X was non-repetitive, it was uniquely identifying everything, so if you split it, it's still the same thing. You just added a extra level here, which is unnecessary. So split command must be used where you can get neat categories out of it. And of course, if we go back to split df, the presence of this dollar symbol says that even if the type of the entire object is a list, this thing is a data frame. So you can, what is contained here is a data frame, so you can check this is dot data dot frame. So is the entire thing data frame? Let's check. No, but is the individual pieces data frames, or the individual pieces data frames? So that is true. So the individual pieces are data frames, but this entire object is not a data frame. Since this is a list, maybe we can call the first one, and similarly we can call the fourth one. Okay, sorry, this is 3. So and so on. Now you can check for this guy as well. So basically you can use split df dollar in the category name based on the splitting protocol that has been followed, or alternatively you can just call that particular element, and as you can see in both cases it says that these are data frames. So now let's say if we wanted to make 2 data frames, so let's say df1, or let's call this df2. So I'll just call this name, or let's call it something else. Let's call it role equals C, or not C, this should go from, let's say 1 to 50, or let's do 1 to 10 for simplicity, and then maybe names equal, let's call it John, Jacob, James, Joseph, Jack. This, yeah. Oh. Sorry for that. Let me type this again. I'm calling roll equals 1 to 5, and names, just name equals Jack, Jacob, James, John, and Joseph. Okay, so if we call df2, so this is one data frame, and we'll maybe use one more. Let's call this df3, and let's add one more entry here. So grade. Let's say AC. This is again a similar data frame, but with one extra entry. So there are different ways of combining them together. So some of the functions that we have already encountered before. Now one is cbind, that if you remember, so it just attaches everything column wise, side by side. So if I do cbind for df2 and df3, what happens is that without any checks, without any discrimination, it just takes the first data frame and then takes the second data frame and then attaches them side by side. So in this same order, basically. This is of course not very useful unless you have unique columns in the different data frames and you just want to combine them. So a better operation is what is called merge. So let's say we want to merge the two data frames, df2 and df3. Now we can choose to maybe sort it. It's a sort by grade. Or okay, let's just merge it first and see what we get. So since df3 is nothing but a superset of df2, the consequence of merging df2 and df3 is to, have df3 in the same order. So, okay, let's do one thing then. We'll keep the roll number and we'll keep the grades, but we'll remove the name from df3. So this is df3 and this is df2. They have basically one column in common and two unique columns. So now if I do merge on df1 and df2, oh sorry, not df1, df2, but df2 and df3, then role, name, grade, everything comes in the same place. There is one more. We will look at merge in some details, but before that I want to mention one more. So that is rbind, which basically does a vertical concatenation. So everything in the first data frame will go first, then everything in the second data frame. Okay. Rbind only works if the data frames have the same names. So let me construct df4 from this. So let's say this was for roll 1 to 5 let's say I want something for roll 6 to 10. And let's change the grades. Someone got a E, then a D, then a B. So this is DF4 and this was DF3. So now if I do merge DF3 comma DF4, sorry, not merge, but R bind. Yeah, if I do an R bind, then everything in DF3 is stored in order over here. So the first 5 elements, then everything in DF4 is stored in order. So the last 5 elements. So depending on the situation, you want to use C bind, R bind, or merge differently. So you use C bind when you know that you are referring to data which corresponds to the same set of entities. So the row names are the same, but each data frame contains non-overlapping, or let's say distinct columns. So first data frame has 2 columns, second data frame has just 1 column, but that 1 column is not present here. And all of this corresponds to the same rows. So then if you use C bind, that will just give you a larger data frame. R bind is used to add entries to an existing data frame. So basically, if you're doing some sort of data entry and 2 people are doing that data entry, first person did the entry for the first 50, the other person did the data entry for the other 50 quantities, and if you want to join them together, you use R bind. Merge is a more intelligent solution, and this works when you have, let's say, one data frame may be a subset of the other, or there may be some common column. So based on that one or more common columns, you can merge 2 data frames. Of course, you can look into some detail at merge. It has some more functionality. So you can see there are these extra arguments, all, by, X, suffixes, no duplication, and so on. So X, Y are the data frames that we want to combine. By.x basically specifies the columns which are used for merging. Sort will basically, using what argument you have given for this by.x or by.y, then based on that, if you give sort equal to true or false, this will just sort the data in order. And no duplication, basically duplicate column names are to be avoided. So you may want to avoid that, you may not want to avoid that, so it's based on that. Okay. So of course you can also run these examples and see some more. But that is basically the content of this week's lectures. I will stop sharing. If you have any doubts, then please ask. No doubts? Okay. Very well then, we'll meet same time next week.